This conference will now be recorded.
Thank you very much, guys. So today's topic is something which yesterday we left out from persistent storage. Yesterday I tried to explain you a lot of things on the persistent storage. What is a persistent volume and what is persistent volume claim, and I hope that you have understood it. And we were discussing a lot on the different issues related to NFS, how to create high availability, and a lot of things were there. Anyway, but we have not deployed the PVC inside the pod. That is one of the exercise left out that we'll complete today. And apart from that, I would like to discuss about the storage classes. And once the storage classes are done, then we'll go ahead with the next topic. So mapping the volumes inside the Kubernetes cluster is the task, right? Think about one situation, and from the, let's say, 12,000 feet above that, you have a cluster, Kubernetes cluster, and you are trying to map something. You want to map some external volume that can come from anywhere. It can come from it can come from the storage box. It can come from the cluster. Sorry, it can come from the cloud service provider. How to map that inside the Kubernetes cluster, right? That was the scene actually we were discussing. We discussed about the different types of the persistent storages. Like, however, the PVC looks very interesting stuff to so that we can deploy the volume. If we can attach the volume to the cluster. So persistent volume claim. These are the kind which are available at the namespace level inside the cluster, so it gets spread across the entire cluster. So that is the solution for mapping external volume to the Kubernetes cluster, so that you can safeguard your data in case your containers or pod gets dies, right? So that is what your top view we have seen yesterday. Right now, let me try to show you. Let me complete the topic which you have just left out yesterday to map to the persistent mapping the persistent volume claim inside the pod. And once that is done, then we guys go ahead with the discussion of the storage class. I would like to spend some time on the storage class, and then we'll go ahead for the
হ্যাঁ হ্যাঁ
next topic. So I request all of you to please
এ
mute.
ওদের ওখান থেকে বাল্বটা খুলে এনেছো মা
Okay, thank you. And now let me go to the my master node. This is my master node, guys. And yesterday we were successfully deployed the physical volume that is called as the PV. And it is right now, what is the status right now? It is showing the bound. That means there is one PVC has claimed this particular physical volume, right? That is nothing but a PVC1. And it shows here, we have created it 21 hours ago. This is as read, write, execute, right? So yesterday what we have done as a preview, we have created one mount point, and we have exported that mount point to the across the cluster with the help of NFS, right? And then what we have done, guys, we have created the PVC, and we have mapped that PVC to this particular physical volume, right? Now you can see here, this is the name of the physical volume PV1. This is the capacity of the physical volume. Yesterday we had discussed about the access mode, that is RWX. RWX is nothing but read, write on many. So many containers can read it. What is the reclaim policy? Reclaim policy is nothing but in case somebody deletes the PVC. Okay, let's say that you have mapped this physical volume claim inside the pod, inside the container, and later on you have removed the application, that container is deleted, and now you think that, or you want to delete this PVC. If you delete the PVC, then what should be the status of the physical volume? Whether you want to make it you want to retain these physical volumes so that same kind of the application or same application can come back and claim these particular physical volume again. Data will be preserved inside the physical volume, right? You can, if you keep the reclaim policy as a written, the same kind of application can again access it. There is another reclaim policy. This is one thing I explained that is written. Another reclaim policy is nothing, delete is there. And what is the meaning of delete? Delete is nothing but when you say that my PVC is deleted, then the same application doesn't have the claim on the physical volume, it is deleted, so that it becomes available again. Reclaim policy becomes available or status become available so that any other application can be, it can use, or any other PVC can use this physical volume. That is nothing but delete. So if you are not interested in the data which is stored inside the PV, right, which is inside the PV, and that PV, let's say that PV has important data inside that, let's say that, and you want to use for the same application again, you please make it as a written. If you have the PVC, if you want physical volume data to be freed up, it is not important, and any other PVC can use it, then you can make it reclaim policy as a delete. And third reclaim policy is there is called as a recycle. So by default, whenever you delete the PVC, it is available for anybody, any PVC. So these are the three values of the retain of the reclaim policy: retain and delete and recycle. So let me give one liner again. Retain is nothing but same PV, even though if you delete the PVC, same PVC, and if you are trying to create again PVC for same kind of application, the data can be used so that data will not be deleted. This PV will not be allocated to anybody else other than that PVC1. If you are using a delete, then that PVC1 says that I don't want to keep a claim on this physical volume, you can use it. Please delete my claim on this one, so it becomes available for other PVCs to acquire it. And recycle is nothing similar like delete only. So whenever it is PVC is deleted, it is available in cyclic form. That means any PVC can access that. Any PVC can make a claim on the physical volume. That is nothing but a recycle. Okay, so I will show you the status of the all the values which come here. Okay, whenever we try to delete the PVC, what value it will show, right? When we delete, so okay, and if you try to again claim it, what will happen again to this one? So we'll see that values as well. Okay, now yesterday we have created a PV and PVC, and what was the I think I have used this particular pv1.yaml file for creating this PVC, sorry, physical volume, which is of 1 GB size. It has access mode called as read write many, and it is a persistent volume reclaim policy is retained, right? And this is a kind called as a persistent volume. It is a 1 GB of size, and the path which you have used is a couscous, right? That is the nice word, and we are using it from the server called as a master. Now that has been mapped inside the PVC. This PVC1 has claimed it, okay, like this one. So whenever now we create a PVC, since the storage class is same, this PVC will be able to has taken the claim on this persistent volume, right? So it is depend on the persistent class, so storage class, or you can say the, yeah, it is depend on the class. uh, okay, if the PVC and PV is from the same class, then definitely it will allow you to acquire it. So PVC can take a claim on that. We'll take some more examples on this one, but let me complete the one example. So for now, what we are going to do, we are going to use this PVC inside the pod. So let's see that how to do that, guys. So, so there is one activity guide. I request all of you to please keep on mute. No, this is not that activity guide. Okay, so we have done this all the steps except I'm just need to check what is the nfspv.yaml, right? So this is something which you have created for the physical persistent volume. We have used this as a nfs-pvc. Okay, and now I want to deploy that inside the pod. So creating a pod to mount NFS volume. So what is the file name? It is nfspv pod. So this is the file name I'm going to use. Let me show you this. vi. Okay, now look at this, how to map your PVC inside the, okay, so inside the pod. Look at this now, guys. So this is the pod I'm going to create. The pod name is www. Its label is also www. And the container which you are using engine is Alpine, right? Its port is 80. And now these are the two things comes up, right? Volume. So what is the name of the volume? Let's say I'm using the name of the volume called as NFS vol. And what is the persistent volume claim? I think it is PVC1, right? We have given it, we have kept the names very normal. So it is PVC1. And this should be again the same volume mounts. Yeah, this is okay. This is NFS dash vol. Right. So what is happening here? Whatever the data you have meant, whatever the can somebody please mute? It is little bit. Piyush, can you mute everybody, please? Yeah. So let me save this. And now we'll see that whether this gets created or not. kubectl apply -f nfspv pod dash yaml and kubectl gate pods -o wide, and it shows that ww is creating a container. So let me see whether it is created or not. Yeah, it is taking some time to create it. Let me see. kubectl describe pod www, and we'll see that what is happening here. So it is showing successfully assigned default ww to worker 02. Persistent volume claim is pvc1, right? It is using this mount point. Cool. Now let's see that what has happened, whether this pod has come up or not. It might have, no, it is still not coming up. Hmm. Yeah, this is correct, right, guys? We have used the volume persistent volume claim PVC1 inside this. Okay, it will get mounted, and this is my, I'm not sure whether this is correct. Nginx Alpine image is there available. It should show. Let me use this. Only Nginx. And so before applying, let me see whether it is created or not. Not, it is not created. So let me apply this kubectl. Apply again. Let me see if there is a problem with the image.
Can you see the describe command to see what error log? Ramesh, last night I gone with this one. Still, it is failing. I'm not sure what happens to this one.
Okay, let me see that. What is the problem? Successfully assigned default. Yeah, now I got this unable to attach mount point called as NFS volume. Oh, I got it now. What could be the issue? Yesterday we did the NFS, and after that, this particular worker or worker two and everything was unmounted. Sorry, it was stopped, right? So I think if I go to the worker two, and if I see there won't be that particular mount point created. So that may be the problem. So this is the issue it is showing, right? See here, mount hyphen t NFS master. This is
Yeah,
creating an issue, right? So I need to now go to the worker two and mount it again. Then it will come up. Okay, no problem. So let's go to the worker two. Let me check out if this IP is correct or not of worker two. Where is my
Ramesh, this is your on-prem cluster or is a cloud
no no?
cluster?
This is a cloud cluster. Yeah, now you can see here worker 2 because this is getting uploaded on the worker 2, right? So let me go here and access it again. Open. Yes, and let me log in. Good, that problem has occurred here because you will get this case study, guys. If NFS is not mounted properly, it is going to fail. So let's see that df-h. Look at that. That mount point is not there. Okay, so what I need to do, guys, I need to uh, use the command control R mount hyphen T NFS. Now the IP address of this mount master also has got changed. So we need to use the IP address of the master again because we shut it down the machines yesterday evening after the session, and because of that IP got changed and NFS got stuck, right? So now let me use the IP
So
address
we
of
are
the
creating
master.
the NFS mount point again, right, Ramesh?
Yeah, just mounting it on the client side. Correct. Yeah, it is mounted now. You can see here now it is mounted. Yeah, that is also, you can use that way also. Anyway, if you use a private IP address also, unless and until you don't make it permanent, it is going to be failed. So it is important that you have to map inside the fstab file of it. Now it is running, guys. Fine. I hope that now this has come up back. Let us see that what is the, let me describe this for. It is showing that connection timed out. So let me see if this kubectl get pods command shows me something. Yeah, it is showing me container creating. So let me now deploy it again. Yeah, now it should work. If it is going on the same worker node, it should work. It is still okay. So let me describe what is the problem, then we can again go and check it. So this is one good R&D case, guys, coming up. So is it coming on the worker 2 now, or it has gone to some other node? That is also important to watch. Yeah, worker 2 only. So I think it should.
I
Mm,
created mounted on both nodes and still it is failed the same thing. Mount-T NFS masters.
okay, okay. No problem. We'll check it. Unable to attach mount volumes, unmounted volumes, NFS wall, attached volume, timed out waiting for the condition. Okay, I think this is showing the recent one, right? Mhm. Transient mount for kubelet and okay, yeah, it is showing connection timed out, but I have this connection running. I have on the master too, it is working fine. This particular mount point is there and data is also there. Okay, so what could be the reason? Ping master. Hmm, this could be the another issue. Okay, guys, let's do it quickly again. In 2 minutes of time, I have all the files ready. So let me delete my kubectl get pvc. Now let me delete this one called as pvc1. Okay, now it is getting deleted. Once this is getting deleted, then you can see the status of the PV. It will show that available. If it is written, it will show written. Why it is not deleting? Because the pod is in the process of creating, right? So that is the reason it is creating a problem. So I need to delete the pod first. So let me do that. Okay, kubectl get pods, and this is container creating, right? So let me delete this. Okay, so pod is deleted. So now once the pod is deleted, then only it will you will be able to delete the PVC one. Okay, so let's see that how it goes. Yeah, the moment the pod got deleted, the PVC also got deleted. Okay, now we don't have any PVC now. Let's try out the PV. Now what is it showing? It shows that status is released. Right now, yeah, it is showing it because the reclaim policy is written, but same claim is given by the PVC, right? That's why it is released. So if I have used the reclaim policy called as delete, it would have been deleted immediately, this one. Now I need to delete this one. So how do I do it? Kubectl delete persistent volume pv1. So it is deleted. Now I don't have any PVs here, right, guys? And now let me do the deployment again quickly with the same file. So we have this vi pv1.yaml file which you have taken it from this. So this is my path, right? And let me see in the activity guide what was the name of the file which I have used. Let me do it quickly, guys, so that we don't want to spend much time on this one because we have discussed a lot. pv.yaml. Okay, so this is showing. So instead of this path, I will just use the path called as what is the path we have used? The path which we have used is this one, right? cd exports. This is the path. So let me use this path, guys. And this is the server kubeadm-master. Let me save this. kubeadm. NFS dash PV. Yeah, so sorry. kubectl dot YAML. Okay, now it is applied. Let's see what happens. Kubectl get PV. So we have created the physical volume. So it is now as read write mode. It is in the retain policy. It is available now and created 4 seconds ago. Now I want to create a PVC for this one. So let's use the same file which is specified. We have used the same files, but small changes need to be. Okay, so now vi pvc nfs pvc.yaml, and that's fine, guys. We are going to use this kubectl apply -f and the file name nfs pvc.yaml. Okay, now you can see here kubectl get pv. It is got bound and get the pvc. Yeah, so it is showing that its status is bound. Okay, capacity is 1 GB. Right? I have not mapped this particular NFS on the worker one, right? It is as it is earlier one. So let me just use, guys, one command here. Okay, now what I will do, I will go to the yeah. Now I will go to the worker one. So what is the IP address of the worker one? Yeah, this is the IP address, worker one, and what happened to this? Let me use from this place only. Okay, so it is 52.138.81.122. Open. Okay, now I am inside the worker one. And now here also that NFS mount point is not there, right? So you can see here this NFS mount point has been removed. So I need to mount it again. So I need to use this IP address, Control R, mount -T. So IP address need to be used like this one, which is 52.146.36.144. Now it is mounted, right? I have opened all the policies also. There is no policies firewall which is blocking it. I hope that it is on and running. Now kubectl. Okay, I need to apply the now deploy the PV, right? So vi, we have that file called as nfs uh, pod, which is www pod. Let me use that one only, guys. Okay, yeah, this is the file. So let me open this file first of all. Yes, and everything is same because I have not changed the names of the volumes, and its claim name is showing PVC1. Let me change this much. So what is the name of the PVC? You can use command kubectl get PVC. So it is showing NFS dash claim. So let me use this name here. Now rest of the things are same. Let me save it here. Kubectl apply -f nfs dashboard. I have one more doubt actually. Let me try now. Okay, so it is created. It is showing. Let's see whether it is creating or not. kubectl get pods -override. Kubectl describe pod www. It is showing it is successfully deployed. Let's see what is happening.
Is
But it is not.
NFS server is running on master? Is it required? I think.
Yeah, it is running on the master. I have just exported that to the all other, but
Ramesh, before this activity, we did the NFS mounts, right? Is that
Mhm.
is causing to this one? Just
No. This actually NFS mount point is required, otherwise it will not work.
okay.
I have not used that method. There is another method which is used, but that method I haven't used. I have a doubt. No, there is a problem. Everything is working fine here. You can see here this is available here, and on the worker 2 also it is available. Yeah, it is available here. You see.
Just try
So,
once again from here, master. Is it the pairing is done? I don't know. It's like,
oh shit, I deleted the border. Sorry guys. Yeah, pairing is done. That is done. Okay, let me deploy it again. Sorry guys. I have one doubt, but here, but anyway, let me check out one more time. Kubectl get describe. So you were saying that peering is done. That is absolutely correct. The data is there inside it. Everything is there on the worker node as well.
in earlier case, like you were not able to ping from here to the master.
Yeah, that is the only one thing is there in my mind. But let me see if it fails because of that reason. Then we have there is one reason for this one is there. That is because what is the file name we have used? And nfs pv. This is a file name pv.yaml, and here we have used the server called as a kubeadm master. Right? If now this fails, then I will change the this name. The reason is that uh, dash master is not the name of the server basically right now. It is something else.
Can you,
So we can
can you
we
give
can use
IP
the IP
address?
address. We can use the IP address. Yes,
Shall we,
that is the one.
in place of this,
Hmm.
we can put the master's IP?
Yes, we can put the master's IP. So let's see that how it behaves now, and then if it is not working, then we'll definitely do that.
Yeah, Ramesh, it still fails, Ramesh. I already tried with the IP address.
Okay. Uh,
I think it is best to put the IP and just.
yeah, one second. Let's see what is happening. We need to identify what is going wrong thing here, right? In the last session, which where I did it, it went well, very nicely, without any hiccups.
But yesterday we had removed this entry from the file.
Yes, I created again. Right now, I created with the normal stuff now.
It says mount volume setup failed for volume PV1.
Right now, let's read this one, guys. It shows that failed mount, unable to attach or mount volumes, unmounted volumes, NFS all default token, unattached volume, this one, timed out waiting for the condition. Failed mount. setup failed for volumes PV, volume mount failed, exit status. Okay. So because of that reason, it is not. So reason is that NFS is not functioning properly here, and because of that, it is not working. So success, unable to attach mount volumes. Okay, so it is unmounted it, and that then it is failed now. Okay, so now what we can do, that is one of the thing we'll check, and then we'll go ahead. Let's see, NFS-PV. Yeah, this is one thing was coming in mind. Okay, and what is the IP address of the master node? Let me try out this now. But first of all, I need to delete that pod.
But again, if we start the VM and try to run it, won't run again because the IP will change, right?
No, IP will not change now. No, till the time your master server is up and running, now that IP will not change. kubectl delete PVC, and this is deleting. Okay, guys, so it is deleted. Now let me delete the PV, and let's delete this. Yeah, it is PV actually. So it is deleted. Okay, so nothing is there now in the background. Now let me deploy it again with the new schema, kubectl apply -f nfs -pv.yaml. Okay, it is created now. So what is the name of the PV now here? Okay, and now let me deploy the PVC. Okay, it is created now, PV, and then created a PVC. Right, it has bound also, right? You can see to the PV volume 01. So it is proper. And if you see here inside the NFS PV, I have used that file also. This is the same file which you have created, folder which you have created. We have mapped it. Now let us deploy the pod now. kubectl apply -f nfs pv dashboard. But let me open this and check it again one more time if anything need to be added. Okay, volume mounts are okay, volume is all right, persistent volume claim is the same name. Cool, everything is fine. Yeah, nfs claim only, right? And let's deploy it now. kubectl apply -f. It is showing created. kubectl get pods -o wide. No, it should get created. Yeah, started now. Yeah, it is started. So that IP address was it was not communicating with the master server. So the IP which I gave here now, that is a important stuff. Please keep this in mind, guys. the IP address which we have specified in the nfspv.yaml file. This is important. Okay, you have to specify the proper, and that's why in case you are creating a master node, but if you are creating your own cluster on premises or on the Azure also, anywhere, make sure that you update the host files of all three machines with the private IP addresses so that you can use the names. Otherwise, it will fail. Okay, is that clear now? Why it was failing? And now, if you see kubectl describe pod www, right, and you can see now it is created properly. Cool. So now,
So for that private IP, we need to ask the vendor, right? Because
no,
if you
no,
cloud,
you can see here from this place. There's a private IP address. This is the IP address, private IP address. Or this IP address is also available here. You can see this is the private IP address of the master machine.
no, this is like, since we have created our own, but in actual, like if it is on cloud, the master will be maintained by the AWS or maybe by the Azure. So
No,
can we do that?
In that case, you can map it on the worker one.
Worker.
So whatever the configuration I have done as a NFS master server on this machine, on the NFS server on the master, don't do that. Do it on the worker one or worker two. It will work. It will work.
Ramesh, you used private IP address or public IP address? I use the private IP.
Now I use the public IP address.
Yeah, when I use this private IP address, it still failed. That's what I am saying.
So just check out your firewall policy security group.
Okay.
You have to allow security group because this requires couple of ports. If you see here rpc info-p command, I hope that this works in the Ubuntu. Yeah, it requires these ports 111, 49961 and 57883. These are the important ports, and of course 2049. So you have to allow these ports, otherwise you allow the traffic. So what are the ports you want to allow for the NFS? This is given by this command rpc info-p, in case you want to allow specifically only NFS.
So
Okay.
we have to allow these ports from Azure, right, Ramesh?
Yes, on Azure firewall.
So
Right
Ramesh,
now,
can you request Piyush to just update it, because in case if you are following the activity guide, you may again land it in the same problem. Maybe after 2-3 days, we might skip it out from the memory.
Yes, Piyush, please can you just update this in the activity guide that we need to open the ports of the NFS in the specific exercise.
And also that instead of using the kube ADM master, we need to use the private or IP address.
Yeah, we can update that document. Sure. Piyush, can you hear me, or who is there? Garvit or Piyush? Please note down this one.
Sure, sir.
But Ramesh, while we are creating the master node and the worker node, at the time we kept like any to any inbound policies. Is that the same thing related to this one?
Correct. Yeah.
So we already kept at the time while we are creating those worker node and master node, we enable the any to any. So in that case, everything it is open, right?
Right. Then everything is open. In that case, everything is open.
But still, the IP address, private IP address, was failed.
See, I'll just check out. Are you able to ping your master's private IP address from the worker node?
That is not happening. Yeah, that is what's not happening.
Yeah, then it is not any to any. And you have to open not only for master, you have to open for all three machines.
Okay, let me confirm on that one. And if I need anything, I will raise a ticket.
Yeah, you have see, I'll tell you one thing. There is one networking concept here, security, right?
Okay, sorry, Ramesh. Actually, I was away. Is this regarding the port opener for Azure? This
Right.
okay. We have a guide for that to how to open ports, all ports on
So,
the Azure.
yeah. The only
Okay,
concern
so
is that, Piyush, we need to update in the activity document tracker that uh, in case you are using different IP addresses or something like that in the NFS file here, we have to make sure that use the private IP address or public IP address of the master server where we are creating the NFS server. So we need to mention that either you can mount this NFS on the master node or you can use it on the worker node also. That one
okay,
liner
got it.
addition is required. That's it.
Okay,
And,
okay, got it.
and make sure that also port openings precisely you can put the star there and say that we need to open the ports any to any in the testing environment. But in the production environment, if you want to see the which ports need to be open for NFS, you can use this command rpc info-p. This works on any Linux command. So they will come to know that which port need to be added in case they don't want to use any to any in the production.
Okay, got ya, Ramesh. Actually, okay, great.
All right.
I will do this. Yeah.
And I think, Piyush, when you mention any to any, just put there one comment that we have to do in all the 3 missions, not only master.
Yeah.
Sure. Actually, when you create Kubernetes cluster in the guide, I already mentioned to open all the ports there also. So I will update all the guides to I will add a note in each guide to open ports in Azure.
Yeah.
So no problem. Thanks,
Yeah.
Ramesh. Okay.
All right, guys. So this is about the persistent volume. One more thing I want to just check. Yes.
Ramesh, when you are mentioning the private IP address, okay, instead of mentioning the public, better to mention the private, right? Why? Because if the nodes are getting rebooted also, still
Yes.
the private will remain always same, right?
Yeah, you have to use the private IP address, or you use if you are updated into etc host file, use the name of the master node or worker node.
Okay. If time permits, please show us that as well. Okay, by updating the private IP address.
So this is simple. Let's say
Ramesh,
that this is IP. Yeah.
uh, if we update an etc host file,
Mm-hmm.
we can use directly name on the YAML file, right? And
Yes.
also
Yes.
need to make any passwordless SSH from master to worker.
That we can do. That we can do.
Now, does it require
Not
for this?
required. Not required. Not required. The reason is that for Kubernetes cluster it is not required, but for the if you are moving from worker node to master node continuously here and there, then for the better administration purpose we use it, but it is not advisable. It is not suggested in the production.
Okay, in real world it is not required. Okay, fine.
No. Otherwise, if somebody goes to the master node,
Yeah,
they will be
right.
right. So this is
Yes.
the way, guys, we need to do it. Right? If I update now, the same way I have to update for the let's say that let me do it
We can
because
add here workers also, right? Worker nodes also. Now we can add it here. So
let me show it right now only because we may require it later on also. Quickly I will do it. Just watch it how I'm doing it. Yeah. So this is my worker master nodes private IP address taken. Worker one, and the worker one's private IP address is, I can find out from this machine. Now why I'm going there. Yeah. IP address show. This is the command to check out the IP addresses, and it is 10.0.0.4. So I'm going on the master node. I'm just typing here, right click, and this is my worker one if I'm not wrong. Oh, sorry. And I need to put the IP address of now my worker two also. So how do I do that? Let me go to the worker two quickly. IP address show 5 place, and this is a 5.
So basically,
Okay.
this exercise is for just if you do this entry, you can access any node from anywhere. from any other node, right?
By using a names. So you don't have
By
to
using
keep
names.
remember
Okay.
your. Yeah, now I can ping. Look at this. Now I can ping master.
Else we need to update the DNS entries with public IP.
Yeah, worker one. It is pinging. Now I don't have to use the IP addresses continuously every time. And make sure that whatever the entry you are doing here in the etc host files, guys. Okay, here. Copy the same entry into worker one as well as worker two. So you can just copy this 3 lines. Go to the worker two. Open the file via etc. And for this one, you need to be a root user. And go to this location and just paste it. Now I will be able to access. I can ping from this place as a master also without any IP address. Look, it is working fine now. Worker 2 as well. And as well as worker 1. And the same entries I need to put it into the, what was that, worker 1 now. Let me go here, via etc host file. So now in future, I don't need public IP address to access my worker node, master nodes or worker nodes from inside the worker node. It is not accessible from the outside since it is a private IP address. That's it, guys. Done. So this is simple exercise. Please follow this one later on. Okay. Cool. Now let's go back to our master node. We have completed this exercise, guys, of creating a PV and PVC and mapping to the pod. Oh, is there any question on this one so that I can discuss further? During the Partha was asking something, right? Oh, there are so many questions. Okay. What all possible are? Sumant, I think we have seen this, right? Status of
Yeah,
status
we
one.
have seen this. Yeah.
For server attribute instead of master, we can, yeah, that we sorted out now. Can you explain what is the storage class means? Yeah, Vivek, we are going to do now this one, storage class. The storage is on master node. You need to export it to the worker node suite. Yes, correct, Judy. You have to export it to the worker nodes as well. Otherwise, it will not work. So we did that mounting, right?
Ramesh, one small doubt. See, if you go for auto scaling of, self healing of worker nodes, okay, we cannot do this activity, right? So that it won't be accessible. etc host placing all these IP addresses and the server names, but during self healing, it cannot be applicable, right? So we need to do it manually again.
No, for that reason, we have another way to export the NFS. We don't have to do this way. There is a very nice another method is available. Guys, just let me just show you here.
Okay.
Just give me 1 minute. If I can show you Kubernetes NFS example. There is a nice example given by in the Kubernetes documentation. You can use that, guys. So let me see if I can show you that. Somewhere it is there.
So the exercise is for what, Ramesh?
I'll tell you that, just 1 second. Where it has gone. Can you see somewhere here NFS?
Yes. Go to the volume.
This
volume.
one?
No, volume. And right side you can see down a little bit NFS.
Right, thank you. So these are the all types of it. Thank you very much. And this is the NFS example. No, this is something. Actually, I don't wanted to show you this. Okay, can you see here? This is mapping all the entire slash. No, this example I don't want to show you. There's another example also. Very nice example for the NFS, but this is not coming up right away. You can use the host. You can use a host name. We can use a host name. I'll just show you guys that just once I will get it, I will show it to you. Okay, so
Maybe you
what I
can
want to,
paste the link afterward.
yes, it is there, but it is very nicely given example, and I will
No problem,
circle it.
Ramesh. We can continue. Yeah, no problem.
So there, in case if you are using NFS, guys, how they are using, how actually it is done. Let me show you that diagrammatic. I just need to create one documentation on that one, or whenever I am going to give this next session, I will definitely cover that point as well. What is it actually? So, listen this carefully. When Tulsiram asked this question, it was a very nice question. So the question is this one. If you have this NFS mounted on any one of the worker node or master node, let's say worker one, I have created one NFS mount point here. Let's say the name of the mount point is /data. Okay. And you need to export that onto another worker nodes as per the NFS policies that it should be available on the worker 2 or maybe worker 3. And if it is auto scaling method, then if automatically the another worker node is getting created, then again you need to sorry guys, then again you need to uh, copy this particular part, and you have to do the manual stuff, right? So you can avoid manual stuff here. So there is one configuration file of the NFS which I didn't got right now, but if you put that configuration file, NFS configuration file, which is a very standard file, config file here, not like which I have shown you, there is another config file, it automatically get mapped here. It automatically get mapped here, guys. You don't have to do it manually, that mount -t NFS command. Because then this particular storage class, which we are going to use as an NFS storage class, that will spread this NFS mount point across this one. And it will create, if required, it will create the mount point also in the required worker nodes. Then you don't have to do that one. So just remind me about this NFS config file, guys, in case I forgot it. I want to show you that later on.
So
Okay.
from where the NFS config file will get the information of the new node which you have.
No, this becomes this. See, basically, this NFS config file which we are using, or NFS configuration which we are using inside this is getting created inside the physical volume, or sorry, persistent volume, and the persistent volume is the kind. Okay, and it is a namespace component. It gets spread across entire cluster. Only matter is that, yeah, only matter is that how we can this /data can spread across the all the worker node. That is the point I wanted to make it here. Okay, and for that purpose we have to have some another configuration file. Yes. Okay. Now what is the storage class? So the storage class is one of the interesting topic to discuss. Right now I don't have any storage class in my default namespace, but do I have any in Kube system? So there is no storage class. So that means it is not connected to any storage right away. So what is the meaning of storage class? So let me explain you this with the diagram. So this is your cluster. But how from where you can connect the storage to this cluster? What are the different sources? You have AWS. You have Azure, and what? You have GCP. You have IBM Cloud. There are so many sources are there. Which are the sources available, guys? There are a lot of. How you are going to plug in this AWS, EBS, or Azure disk, or maybe GCP, some other, it is called as persistent disk or something like that. In the GCP it is called as. How, or if we have a OpenStack, that is a Cinder will be there. There will be Safe, there will be Gluster, lot of different storage types are available. How you are going to plug in here all these stuffs to this cluster? So if you want to map this volume and plug in inside this AWS cluster, and from that you can create a physical volume. So first of all, I need to have this external storage or volume. I want to add this into cluster, so I need to create a plugin. So once that plugin is created, then we can use that plugin kind of stuff inside the physical persistent volume. And from the persistent volume, you can create a persistent volume claim, and that you can attach it to the deployment. So the plugin which we create to map the external volume inside this Kubernetes cluster is something called as a storage class. What are the different types of the plugins are available? See here, now I have just copied it in this my notepad. Okay, so persistent volume types, this is defined and inside the persistent volume types are implemented as plugins. And which are they? They are AWS Elastic Block Store, EBS is there, Azure is there, Safe is there, Cinder is there. Look at this, how many of them are there. And you can see we have local also, we have iSCSI also, we have created host path also yesterday. That is also persistent volume type. This is also one kind of the plugin we are using. We have Flocker, we have Flex Volume, we have Fiber Channel, we have a lot of things. NFS is also there. This is also one of the persistent volume type plugin. Right? So can I define the storage classes for this? Yes, I can, because I want to insert this particular plugins inside the cluster, and to do that one I need to define the storage classes. So how to do that one? Let me show you. So I have storage class called as a SC1. Let me show you this diagram. First of all, YAML file, and this I have taken it from the AWS EBS. So this is a storage class. Who is the provider or provisioner? It is the AWS, and its parameters, like it will be GP2 or what will be the, this is reclaim policy is related to the kind, but this parameters comes from this particular plugin for this plugin. So now if I define kubectl apply -f sc1.yaml file. So my storage class is created. This my plugin is created inside the cluster, so that I can use the EBS now, right, from the AWS kubectl get storage class. Can you see? I got the storage class created for this AWS EBS. Reclaim policy is written. This is immediately available now. And allow volume expansion is nothing but can you resize it? Yes, I can resize it. True. 12 seconds. This is for AWS. I think one more is there for SC2. Yeah, it is again for the AWS EBS, but I have used more parameters here. So this is my IO1 type of the disk kind of stuff is there, whose IO ops are per GB are 10, just 10. It is very slow. That's why the name is given slow. It is, you can give any name to this one. And this is kind of storage class, and this is a file system type which we are going to use, that is ext4. So I can deploy this kind of plugin as well, that is a storage class for the AWS EBS. Apply -f sc2.yaml. Now you can see there another storage class. I got it. Now if you want to get the, let's say from Azure, then how you'll get it? How you'll plug in that inside this cluster? So let me see if I have this one. So this is from GCE, actually it is coming GCE, Google Cloud. This is PD stands for persistent disk, right? And these are the parameters of that particular provisioner. And let me save it. So I can create a storage class for this also. And there are so many, guys. Let me show you SC7. This is coming from my safe. This is called as a safe, actually. Provisioner is RBD. What is RBD stands for? RBD stands for Rados block device. Rados, that is a safe storage. One component is there that is called as the Rados, and you can save this and you can just create it. So I want to use Rados here, or I want to use safe storage. I will deploy this storage class inside my cluster, and then you can see that it is got deployed also. Not PVC, sorry, storage class. And these are available now. So what is a storage class? In short, if you want to use any external storage or any kind of storage type, if you want to use inside your cluster, you need to plug in that type of the volume, persistent type of volume inside the cluster. To plug in it, you need to define that as a storage class. I hope that it is clear now. Any questions, please ask.
So the reclaim policies for individual plugins are defined inside the YAML file, right?
Yes, yes, it is defined in the YAML file. If you are not defining it, is by default it is delete.
Delete. And the allow volume expansion, that is also defined?
Yeah, you can define that also. Correct.
Okay, if it is not defined, by default false, right?
False. Yes, yes.
Okay.
Correct.
So do you remember, I mean, do you know the location of the NFS config file on top of your mind?
Right now?
Just want to see. Yeah, I mean, if you remember, otherwise we can discuss this later.
Yeah, this is that persistent volume.
No, Ramesh, I'm talking about the NFS config file which you have shown us, right? Where the mounts can be automatically mounted. Okay.
Not here. We don't have to specify here anything.
Okay, I know. I'm talking about the diagram which you have shown us. That is a NFS config file only, right?
No, which one you are saying? This one?
Yeah, this one. Yes, NFS config file.
No. This is different. This file
Okay.
not. I have not got it. Once I got,
okay.
I'll get it. I'll show you that one.
Okay.
Okay, guys.
How do I make sure? Like, say, since it's a plugin means from external, so if you are getting into enterprise, there'll be first question will be like security and all those things, right? So does it take care of all those aspects, or
enable the encryption? Have the REST API with HTTPS call.
Is it like it's not like a layer 4 based on based on certificate or anything, or is it just endpoint invocation?
No, you can create an endpoint, secure endpoint. You can use 6443 or 443 protocol, HTTPS or TLS. We can use that one to access that. If you want to access any storage from the AWS or something like that, right? You need to get authenticated first.
Correct.
Right now, I am not able to. I will not be able to show this exercise to you guys, because why I'm not showing it to you right now, because I have not deployed enterprise level Kubernetes inside the Azure. If it is there, then it will be easy for me to bring the disk from that particular stuff. But if I want to bring the disk of the Azure or AWS in my on-premises network, okay, I need to get authenticated. I need to create a direct connect or something called as VPN or some other VPC kind, HTTPS kind of call need to be a secure call need to be made to the storage box on the cloud. It has to be secure.
It has to be secured means from my cluster side, I need to have a YAML file which will have the configuration of mutual TLS, and those configuration will come there, or?
Yes, right, Abhiram.
Do we have a sample there, Ramesh? I mean, I just want to know, because practically.
What I will do, yeah, I got it now what you're saying, but we have a dynamic provisioning session. Okay. In that one, I will show you. Right now, it will be difficult to show.
No problem. So within this, I know you showed AWS, and there are multiple. I mean, I even don't remember the name. So what are the choices? Do you have any choices recommended? How do I mean? Because if I'm talking about what are plus minus, or I don't know whether maybe in any aspects.
Storage is storage.
Okay, there is more. Okay.
It comes from any cloud service provided. It is a storage. Only what is the choice? if you are connecting, whether it is secure, is it easy to use, right? Is it going to integrate immediately? If I tomorrow, if something in the background, if hardware gets upgraded, and if the storage box get upgraded, will they provide me the integrated keys, or will be there? They will provide the updated version of it automatically. I don't have to do anything. So the service provider who is having all that kind of stuff, you should be using that as a priority.
And of course, IOPS, I think.
Yeah, of course, that is operational level. But I think he was asking which one I should choose from this one, right? Which you see on the screen, right? So
If there are, I mean, I was just not sure because sometimes what happens is when we propose to client with this multiple option, they immediately ask on like, okay, what with your experience, tell me which would be, that way.
That is very tricky. That is very tricky.
Yeah,
So
yeah, I know.
for that, yeah. So for that purpose, what you need to do, Abhiram, as per my experience, that ease of use, safety,
Okay.
upgradation policies, and the cost.
Yeah, cost is the first one, but I correct.
So Ramesh, which one is more popular?
Where popular, we make it popular, right? We make popular. In everybody's mouth there is a EBS, right? Do you know Azure Disk? Do you know Safe? Safe is a fantastic storage, but we don't use it. It is not marketed that way. But popular is, of course, popular. I think almost 70% people are learning either AWS or Azure, and that is has been taken by, and most of the customers are also like to go there. So I think overall the popular is, you can say, AWS and this Azure only. But GCP is coming like anything, guys. Now that is the space to watch. Okay.
But again, Ramesh, one thing, from a practical perspective, if we say that okay, one is popular, one is how the cost is. But again, from your experience, how do you think like okay, if I have a dev or sandbox, okay, this type of storage. If it is pre-prod, this one prod. So I may go to AWS, but again, do we have like a smaller places, different? I can use that way also, right? This storage and I'll have a like cheaper, or that also can be done, or is that a bad idea? I don't know.
No, no, no. If you are using let's say you are having a Kubernetes cluster deployed on the let's say if it's deployed on the Azure, it is convenient and it is easy to use their storage only. Don't go for the AWS. But if you have on-premises Kubernetes cluster deployed, then it is always better to use your own storage box rather than going for any cloud service provider.
Oh, because the on-premise one is easy to manage and it's on my hand. Is that the way?
It's in your hand, and the latency will also reduce.
Oh,
right? You will have the more fiber optic cables you can put it inside that, and you can have better performance.
Okay,
but nowadays, like even in enterprise or in a big organization, people are going for hybrid model. Means like
yes.
Some part of might be working on AWS, but they are using Azure as a DevOps tool, and maybe like they are using some other vendors. So
I have one thing to say, Ramesh, here, that if you are using the on-premises or hybrid model, hardware should be at one place. Services can be taken from the cloud. You can take the DevOps CI/CD services from them, right? But make sure that your hardware is there inside. If you are using hybrid kind of stuff, it is always convenient. In the enterprise level, if it is a small level where hardly 400, 200 users are accessing it, hybrid also will work fine.
Okay.
And to start with, Ramesh, like how do I calculate its storage? Okay, this much I want as a storage. So any environment. So that will be like if that question comes in.
Yeah, I'll tell you this is the last question I'm taking for the particular discussion.
Okay.
The reason is that for the capacity planning, we can discuss
Okay.
on the storage
Okay.
Yeah, capacity planning. Let me tell you that one. What is the size you need to define, right? So first of all, the person who designs the database, right? We need to take care of that guy. We have to discuss with him that how much data, if your one transaction is happening from the customer, let's say what is the data it is getting accumulated on for one transaction. Get that data, calculate it, go for the 100 users, go for the 500 users, check out how much data is required, and then add some 50% storage on that one, and then give the customer that, look, Down the line, if you are going to get this many customers, database size will be this much, so we'll require this kind of storage. This much amount of storage will be required. You cannot give it in the ad hoc basis. If you are giving in the ad hoc basis, you are going to completely fail, because there is a possibility that today you require a 1 GB database. That customer requires only 1 GB of the hard disk to store his database, and we are asking him to get it for a 1 TB, right? Why? On the general ad hoc basis statement. That is absolutely wrong. We have to do the testing. We have to take care of the database guy into picture. We have to test it for the 1 transaction, go for the 10 transaction, go for the 100 transaction, see the volume size, how it is increasing. And then you can, on the basis of the 100 transaction, you can say that, look, down the line, if your customers are going to be 1 lakh, this many storage boxes will be required. Tell me how much I should buy.
Can we use this container services, okay, for hosting a database of 10 terabyte? Do you think is that, I mean, have you seen any such cases?
You can see databases are available on the disk. Container is just one of the utility you use. Container is another VM. Container is another server. You can use it.
I understand, Ramesh. No, but my question is,
I have
whatever
not
you are
seen.
saying, that's
I have
true.
not seen.
That's
I have not seen.
yeah. No. Whatever you are saying, that's true. But then storage, that is different. Containers is just for a functional purpose. Okay, but then I understand that. But then to make, I mean, if you have a 10 TB database and storage is, if you are using 10 TB, okay, then your application might need that data for day-to-day transactions, right? And that's the reason why you have that storage. So whether your database should be capable enough, okay, to process those transactions. Okay, like if you are hosting a data warehouse environment, what is going to happen?
Container can process any number of transactions, guys. I can apply 127 volumes of EBS inside one container.
Okay.
Okay, it is possible.
Ramesh, that is the maximum.
So there is
that is the maximum volumes we can attach to container.
Yes, if there is a definition given, there is an application benchmarking done by every this cloud service provider, yeah, every other third-party utilities, that how many containers we can use inside the Kubernetes or container from EBS or from Azure Disk. I think in Azure Disk, I think if I'm not wrong, it is 27 or something like that. And I think from the GCP we can add 7. Okay, the numbers may be wrong. Numbers can be up and down, but this they have defined the values that this many volumes we can attach to the container.
Okay.
Ramesh, one last question. I mean, yesterday we have discussed about resizing the PV and PVC, right? Can we practically see that if you resize a PV, whether it is getting dynamically allocated to PVCs?
So that session, that you can remind me that particular stuff in the dynamic provision lecture. I will definitely show you that.
Okay, thank you, Ramesh.
Yeah.
Ramesh, one question about the can we have this fiber channel example in the YAML file if you have it somewhere?
Fiber channel one. Let me show if I have. I don't remember that now which one I have used, but let me just check out if my I'm not sure. This is for Cinder, which is coming from the Nova. I need to pick up that one. I need to pick up, I think, Sarabji. I have read it. Yeah, this is coming from the cluster. This is coming from the cluster, not from the fiber channel. Okay. But right now I don't have. I may need to fetch it from somewhere, right?
No problem. If you can get it tomorrow or later in next week.
Yeah, really, sure.
Thank you.
Sure.
Thank you.
Yeah, thank you. All right, guys. Thank you very much. Let's move ahead with the another discussion now. I hope that everybody has now comfortable with the volume. Look at from the top. Don't go inside the configuration of the configuration of the YAMLs or how it is done, right? We should always think as a solution architect. We should always think this is my cluster, And now I want to attach the volumes here. How I should do it? What should I do? Which type of the volumes I should use? Do I use empty directory? Do I use something called as a persistent volume? Yeah. So in the Kubernetes cluster, we should use a persistent volume. Now, what type of the plugin I should use? Oh, I have my Kubernetes cluster is on the, let's say, Azure. So I will use Azure Disk. For example, I'm thinking. So then pick up that YAML file, try to get the disk from the Azure and define the storage class, create the PV out of it, and then start deploying it to the clouds by creating a PVC. So always think from the top level. If you go inside the problem becomes a big problem. Okay. I hope that is now clear. So can we move ahead now? If you allow, to the next
Yes,
topic,
Ramesh.
scheduler.
Yeah,
Scheduler. No. Thank you very much. I think now it is 10 minutes are there still, but let me just 1 second, guys. Okay, so let's start with the next topic. Our next topic is scheduling the pods on. How do we schedule the pods, right, on the nodes? That comes under the topic called as advanced scheduling. Okay, so where is my advanced scheduling? Here. Okay, so let's see now what is advanced scheduling. So the name itself says that I need to schedule something, right? And what we need to schedule, where to put our workload, whether I want it on the worker 1, worker 2, worker 3, worker 4 for specific reason. What could be the specific reason that there are, let's say, 5 worker nodes are there, and one worker node has a higher configuration and it requires quite of higher CPU or GPU, GCPU kind of stuff where graphics is there, and you want to use that particular worker node for the graphical installation or for the deploying that kind of application on that stuff, that worker 5 only. Then how we can do it? Because if you remember, by default, kube schedule is the one of the controller, or you can say one of the important entity which is available on the master node, which is a default scheduler, right? It is called as a default scheduler, and it decides depending on the couple of parameters on which worker node this workload should go. I mean, this pod should get deployed. It is defined by the scheduler. So that is not in your hand when you are using a default scheduler. So can we tell scheduler that, look, I don't want to follow your all the parameters. I want to follow my parameters. I want this application or this pod to be deployed on specific worker node, maybe worker number 2 or worker number 3. So if you tell the default scheduler that, look, please deploy this particular pod on this particular node, scheduler will do that job for you. Okay, and that is nothing but you can say kind of advanced scheduling model. Okay, so scheduling is an optimization process, right? So what is the need of the scheduler? Basically, for the high availability purpose, scheduler is required, right? Something goes wrong with the one worker node, then on other worker node, if you have the pods of the same application, right? So it will be, application will not go down. So it is down. So it is an optimization process. It is a high availability process. The task of the Kubernetes scheduler is to choose a placement, right? And how it is done? Done by the 2 steps. One is a filtering. So what is the meaning of filtering, guys, here? Filtering is nothing but you have, let's say, 2 or 3 worker nodes here. Let's say this is your worker nodes, worker 1 and worker 2 and worker 3. Let's say 3 worker nodes are there. And now scheduler is now got the proposal from the API server saying that we have to deploy the 5 pods of the same application. So how the scheduler will decide on which worker node how many pods need to be deployed? It says that go to the worker 1, deploy 2 here and deploy 2. But how this calculation is done? The first one is a filtering. What is a filtering? Filtering is nothing but if there is one more worker node is there and which is not healthy, which is having some problem, which is having high CPU utilization, or maybe it is not responding. So what kube scheduler will do, it will filter out this node from the deployment schedule. It will say that don't deploy the pods on the non-healthy worker node. So that is one case. What is the second case? Second case is now out of these 3 worker nodes, on which worker node it will deploy the pods now. So that is called as a scaling or weighing. So it is dependent on resources availability. In this particular worker node, if you have more CPU and more RAM is available, it will try to deploy the 2 work pods on this one. Then it will check who is having in the next line. On that it will deploy 1. Then again it will check who is in the next in line. Then on that one it will deploy 1. So after it finds, let's say that this application is deployed, and later on it finds that scheduler finds that this worker node has a more resources. So next deployment will start with this one. Then it will come on this one, then it will come on this one. So it definitely calculates the CPU and RAM utilization, resource utilization. It gives the point to it. So right now all of them are, when the cluster is formed, all of them are 10, 10, 10. Let's say this is 10, 10, 10. Now you deployed 1 pod. So 1 pod is available on this now. So this becomes 9. This becomes 10, 10. One more thing comes, then this particularly worker node scheduler says that already it is 9 points are there, deploy it on this one. So now its point will also become 9. This is 10. Third pod comes, it will get deployed on this one. Then now the point are 9. Again another deployment comes, but with the higher resources or something like that. That time again it will try to see on which worker node the CPU and RAM is more. So it will calculate the points, and accordingly it will say, oh, this is having 9.0001 slightly more. So then it will put it on this one. But later on it will try to put 2 pods on this one. So it will become, let's say 7 point, it will become 8 point, this will become, let's say 6 point. This balancing act will go on and on, guys. So more the points are there, kubectl will try to put the particular pod on the or workload on that particular resource worker node on which these points are more. That is called as a scaling or weighing mechanism. So that is the second point. So this is something called as a scheduler determines the set of feasible placement, the set of placements that meet a set of given constraint. That somebody says that, look, I don't have something called as this particular pod is not allowed, this particular worker node is now not in the scheduling mode. It has been drained, it has been cordoned off. Please don't use. That is one of the thing. Another one is that unhealthy, then it will be also removed. So that is nothing but a filtering out. And second one is scoring, scaling or weighing. It is called as a scoring is nothing but that is what I was trying to tell you. Scheduler determines the set of viable placement, the set of feasible placement with the highest score. So I think lowest one is 0 and highest one is the 100. That is the way it is calculated. And you can specifically define based on the scoring also that please put the deployment on this worker node whose scale is something called as 10 or score is something called as 10 or more than 10. That also you can define, guys. Okay, so what are the different types are available or features are available by using we can deploy the pods, or we can schedule the specific deployment or pods on the specific worker nodes. One of them is a node selector. So we are going to see in the detail how to node selector works. I just want to deploy the pod on node 2, worker 2. whether it has a less amount of space or whether it has a higher amount of resources, no matter. I just want to deploy it on the node worker 2 only. So how I can deploy that? We can label this worker node. So these are the worker nodes 1, 2, 3. And you can label this worker node. Let's say this is my worker number node, or this is my, let's say, number 1. This label I can give number is equal to 1, number is equal to 2, number is equal to 3, or I can give another labels also. This is my app is equal to prod 1, app is equal to prod 2, app is equal to prod 3, and I want to deploy my pod on the worker node whose label is number is equal to 2. I want to deploy the pod on the worker node whose label is disk is equal to SSD, right? Then your scheduler will not think about other, it will filter out other all nodes and it will just deploy the pod on the worker node whose label is matched inside the YAML file. So it is a constant based filtering. So this is also one of type of the filtering, that you don't want to place the pod on the label which is not matching. That comes as a filtering, right? So this is called as a node selector. So based on the label, you can select the node and you can deploy your payload on that, right? Then there is a node affinity and node anti-affinity. These are the two options are available. So node affinity is nothing but deploy the pod on the specific node, and node anti-affinity is nothing but do not deploy the pod on that specific node. Okay, we'll see that one in detail. We'll see that one. Don't go here. Just think about this one only. Node selector. So is this clear now, node selector, guys? Any question about this? Okay, thank you, guys.
So if one Ramesh, if node selector, if he guy says, okay, this label, you go and take the pod and put it. If the only thing is error condition, I was thinking if it has error, then it is going to pending, right? It won't go to the next one, right? I mean, that pod
No,
will
it
be.
will go to the next one. There are two conditions inside that one that we'll discuss.
Oh, okay. Okay. So it will go to next one. So I don't know the next one. Okay. Fine. And who defines this, like advanced scheduling? Like, is it something like
Developer YAML file, inside YAML file.
No. I mean, now that's fine. You are talking about implementation, but again, in enterprise, will it's driven by business? Those kind of, whether I need to have advanced scheduling or a typical default one. How does that comes on? Like whether I need an advanced scheduling. So that's what I was thinking. Like is it
No,
from? I know.
that depends on. Let's say that you have a maintenance activity, and you want to deploy your pods on one node. So you can deploy, you can move, you can select the specific stuff application on the specific node. You can cordon up the other worker node, and you can say that please do not deploy any pod or deploy the pods on this node only. So maintenance, sometime in maintenance activity also we can use this kind of stuff. So let's say that maintenance is going on, but you don't want your developers or your administrators to stop their deployment. So that time you can say you use this node selector. So they will deploy the pods on that particular point. This is one thing. And the selection definition, it depends on the type of the application you are deploying in that cluster. So if you have a specific requirement of your application where you need more number of CPUs and more number of RAM, which is available in the specific node, you can use it. Or if you have more number of, let's say, concurrency, you have more number of, let's say that, or your application is a graphical application, and in the worker too you have a GCPU or GPU both there, right? That GPU, we say it is GPU, right? So you can use that worker node for that one. So it is specifically on the hardware type also. In the my worker 2 I have a SSD hard disk. In worker 3 I have, let's say, magnetic hard disk. I have on worker 1 I have less provisioned or IOPS provisioned hard disk. I will say that please deploy my production application on the worker 2 only. That way also you can do it.
So in
Right,
case of
Abhiram?
in case my container services is available in cloud, okay, and so I don't have control over master, and kube scheduler is going to run from the master, so that means the end user don't have any option to select where I should route my work.
No, you have. See, you don't have access to the server, but you have a jump server. So here from jump server will authenticate to the master node, and from this jump server is nothing but your Linux machine or Windows machine, any machine which you have on your laptop, or any machine which your organization says that you should access from this particular step, this cluster. That machine is called as jump server. So you are here, you will log in into this machine, and from this one you will say that you will use the kubectl command here, and that kubectl command will give the information to the API server which is there in the master node, which is there in the on the master node, which is there in the Kubernetes, which is there in the Azure cluster or the Azure cloud, let's say. And then you can control. You don't have a direct access to this one, but you have API server access.
Okay, so through YAML file we can control this, right?
Yes,
I mean,
yes,
we
through
can mention. Okay.
Yes.
Okay. Thank you.
Ramesh,
Okay, let
can you
me
please
just take.
explain the thing which you told about the label when you are using the node selector? Can you please explain once again?
Yeah, sure. I'll explain. No problem. Label is nothing but that, let's say that you have 3 labels given: label 1, label 2, and label 3. And now you will write a YAML file, and in that YAML file you will say that, look, scheduler, kube scheduler, I want my pod to be deployed only on the worker node whose label is equal to 2. Right? So what it will do, it will select the node whose label is equal to 2 here, and it will deploy the pod. That's it. So deploying the pod basis on the label is nothing but a node selector.
Okay, means the labeling can be given. Means how the label can be given to the node,
Yeah,
because
that we'll see. That I'm going to show you in the now in the practical.
okay,
Practical, I'll show
okay,
you that.
sure, okay, sure.
Let me just complete the questions and then we'll go for the break, guys.
So Ramesh, what I understand is like, so what you're indicating is makes sense, which is like maintenance or more of a capacity of application, like as you said, gaming. So this advanced scheduling is a concept where as an architect I should know that, like, okay, this is not from a business angle, it's more from a technical and those aspects of capabilities where I need to understand that, and then I have to do advanced scheduling. It's I mean, what I mean is like, it's not okay, business is not going to drive this, right? I mean, it's just that I have
Business
to.
is not going to drive this one. Business should know this one because the cost will be there. If you are
Oh,
going to
okay.
use if you are going to use the CPU and RAM very, very heavily, okay, so the cost will increase, right? So that time we need to do.
Okay.
Okay, cool. Now, Sumanta is asking that, so advisor is going to help the scheduler, right? Yes. From the advisor, C advisor kubelet to API server, and that information will get stored inside the etcd, and API server will, scheduler will use that one for taking the while doing the selection.
Okay. Thank you, Ramesh.
Yeah. If node selector have issue, then pod goes to pending. Actually, I was thinking about Abhiram, that required phase and required and preferred, that 2 conditions. We'll see that one now, whether it goes into pending or not.
Okay.
Yeah. Yes, so Sarabjit ji, we will have a break now. Okay. Thank you. So I think now, what is the time now? As per my watch, it is, okay. Now we'll have a 10 minutes break, and once we'll come back, guys, we'll start with deploying the advanced scheduling concept. All right, guys. Thank you. Let's put the race now, duck race, right, guys, so that everybody will enjoy it.
This conference will now be recorded.
Okay, thank you guys. So let's start with the node selector now. How to label the nodes, how to find out the labels, and how to deploy the pods on that specific node. That we are going to see, and then we are going to slowly understand its depth of the advanced scheduling. So kubectl get pods. A lot of pods are running right now. Let me just clean up this work, guys. Kubectl delete deployment. What is the name of the deployment? It is Nginx deployment, right? Okay. Kubectl delete pod. Can I use like this one, guys? My Nginx, my pod, my pod one. So it is getting deleted as well. I wanted to delete the www also. Kubectl delete pod www, right? So it's done now.
Ramesh, I got a question over here. So in the real-time scenario, we can deploy multiple applications and use multiple pods and that. So how do
No,
you
voice.
do that? I mean, when I say for some reason if there is a issue with the server itself.
No, your voice is breaking, Rishi. I'm not able to hear properly.
So
Please, just help me with that.
are you able to hear me?
Yeah, better now, a little bit better.
Okay, so in a real-time scenario where we are running multiple pods for multiple applications, and if there is an issue with maybe mount or some system issue where we need to restart all the pods, everything right from scratch while moving all the content to another server. How do we do that? Do we run some shell scripts internally calling all the YAML files?
Rishi, we can't hear.
So basically,
We
what
can't
I
hear you
understood,
properly.
yeah, but basically, what I am trying to understand from your little bit what I gathered is, in case some pod goes down or due to some system issues, how do we start it, or how do you move that to the another worker node? Is that your
No,
question?
it's not just one worker node. I'm talking about all the pods, all the applications to another server. For example, the master node. We have multiple YAML files, and we might, if I want to deploy all of the pods, everything, do I run using a shell script internally calling all the YAML scripts?
Okay. Is this your question like this one? Let me try to understand now. You are saying this is your worker node, two worker nodes are there, and there are certain pods running here, certain pods running here, and this has gone down.
No, my question is if my master node itself has gone down.
Oh, master node has gone down, right?
Yes.
So whatever the current deployment is there, that will be running. It will not go down.
Okay.
So if you are right now, let's say 5 applications are running this in worker 1, worker 2, and suddenly your master node has gone down and you don't have any high availability for that, right?
Right.
So the applications which are right now running, they will be running there. They will not go down.
Okay. My question is related if I want to restart everything from scratch. If I have 1,000 applications with 1,000 containers, and I can't just do everything manually. I want to do kind of automation on that. So can I use one shell script and internally call all the YAML files? Or maybe I will place all the YAML files in a particular folder and run all the YAML files from that folder.
Yeah, basically, what you can do in such case, if everything has gone down and if you're starting it, uh, you have a init containers which are running inside the pod. They will take care of it to start it automatically. And if it is because it is a because it is there is a pod or deployment is there, that's why it can control it. But if it's the static pods are there, then they will not start. Then you have to start them manually. Okay, and if at all you want to run the pods as a static pods, or if you want to run the pods while starting itself, you need to write a script for that one, or you keep the
Yes, I'm talking about that particular script. Is it
yeah
going to be kind of a shell script, and internally I will call all the YAML files?
yeah, it will be shell script. So basically, all the YAML files are there in the etcd folder. Okay, so when you start anything which is controlled by the controllers, probably it will not require any etcd or any shell script to start it. It will start automatically because controllers will invoke it. Only thing was if there are hundreds of containers which are pods are there, which are static pods, which are not started by any, which are not controlled by any controller. For that purpose, you need to use a script to start it.
Okay, okay, all right,
And,
thank you.
and another very important option is that you can create, if that, let's say it is very important application, and you can create a container as a service also. Okay, the way I have we are deployed the NFS and we started it, right? The same way we can create a that container as a service also. So whenever your server starts, it can start it automatically.
Okay, I
But
understand.
it is a Linux level stuff, so that
Right.
can be done. Yeah.
Okay, okay. Thank you very much.
Thank you. Okay, guys. So now let's delete this one. I think everything has been deleted, cleaned up now. I don't have anything in my kubectl gate pods. Okay, cool. Yeah, it is terminating. Cool. Now see, guys, how many nodes are there? Gate nodes, and how to see the label of this. So there is simple command: kubectl gate nodes hyphen show labels, and this will show you the labels, right? So now you can see here, these are the standard labels are there, right? Such as it indicates something. This is basically, you see, it shows that AMD 64, this is Linux operating system. So these are the well-known labels. This is the name of the master, hostname master, right? So these are the well-known labels are there, right? But additional labels, if you want to apply other than this one, how do I do that? kubectl label node. Which node you want to label? Let's say you want to label worker one. What is the name you want to give? Do you want to give the label called as something called as app is equal to production? Worker one or
It is
worker one
worker
dash.
01, I think. It is
It
worker
is
hyphen 01.
yes, right, correct. Now it is done. So you can see a kubectl gate nodes hyphen show labels, and now you should be able to see worker one, right? Can you see somewhere this label, guys? App is equal to prod, not got deployed. Where it has gone?
It is there.
It is there.
Yeah, after version, of first.
We can see the highlighted one. In that only we can find out just next to the version.
I got it. Okay. I got it. Right. This is app is equal to prod. This is the label. Can I label the same worker node multiple times? Prod one. I can use, but I can use app1 is equal to prod1, something like this one. Key should be different. Value can be same, but key should be different. Please keep this in mind. So you can see it is now showing app1 is equal to prod and app is equal to prod. Now this label we are going to use to deploy our pods on this one. So right now we don't have anything on the pod, right? Gate pods -o wide. We don't have anything running on worker 1 or worker 2, right? It is blank.
So if you want to delete the label, how you can do?
Okay, so you want to delete the label? Yeah, this way you have to delete it. So now this has gone. App1 has been deleted now, you see. You have only app prod. Earlier it was having app is equal to prod1 and this one right now. Now it has removed and it is only app prod. So you can remove that one. So this is the command you have to use.
So minus is the delete at the end of the level.
Yeah.
Okay.
You have to delete the key by using minus sign. So you have to specify the key, not value.
Okay, okay.
Okay, guys, thank you. Now let's.
Thank you.
Yeah. So now let's write our YAML file so that we can deploy the pods on this one. So do we have any YAML file as such for the node selector?
So Ramesh, if you selected the labels, let's say you have two labels defined, one for worker 01, other for the worker 02, and you want to selector will be worker 01 and the worker 02 labels. So the pod will be deployed in both workers 1 and 02 also, both, right? If we selector can select multiple labels.
Yes, yes. Okay, if the label is same on the both worker nodes, okay, then only it will
No, well,
work.
no, it's a same or doesn't matter. If it's the same, then yeah, that's another question. How it will going to deploy if both has the same label, worker 1 and worker 2. And the second question is, can we selector can be based on multiple labels?
Okay, let us see that one. Just let me try to show you with the help of examples. Okay, let me complete this one, guys. I hope that you will get more questions again. VI. So let me use which pod I should use. Okay, let me see in this one because label dash deployment here. Okay, label dash deployment is there. Now this is my deployment, and can you see it is showing apps v1. This is deployment. Don't forget this API versions, guys. This is Nginx deployment. This is replicas are 2. This is my container. This is a template, and see here node selector. Node selector is the property of pod, right? Not the container. Node selector is the property of the pod, and I am here. It is written disk type is equal to SSD. That is the label we have used, right? Already, it is the definition here. Already that is having. So I am keeping it as it is, and I am writing here app is equal to prod. I don't know whether app is equal to prod but it still exists or not. Okay, so the pods will get deployed on the labels on the nodes whose labels will be matched here. So let me try to deploy it.
You need to give the hyphen. It's an array.
No, this key value, it is not array. Save. Kubectl. Apply -f label dash deployment dot YAML. Yeah, it is deployed. So which node we have defined as a worker? I think it is worker 1, if I'm not wrong. show get nodes hyphen show labels. I think it was worker one, if I'm not wrong. App is equal to prod is worker one, right? Now all the deployment pods which are deployed right now in the cluster should get deployed on the worker 01. So see a kubectl get pods hyphen o wide. It is still in the pending state. Why? Okay. Let's watch for some time. Since I have applied multiple node selector, let me watch. Let me describe this because this is
I
going
think
in.
in the YAML file you have put app one. Can you check that YAML file?
I think app is equal to prod also have kept, if I'm not wrong. Yeah, this is also there. So if it is not found this one, then it should go there. Let us see whether because of the multi this one it is failing. I want to check it. Kubectl describe deployment called as nginx / deployment. No, it is not picking up this one, first one. So it is not going to the second one. So I'll do one thing. Let me open the file and just remove this disk type, first one, and let it this app is equal to prod and deploy this one again. And let's see now whether it is picking up or not. It is also going still in the.
You need to replica set needs to be scaled up.
No, it is there. No, it is not running only. It is not coming up only. Pod is not coming up because it is not getting that worker node which is labeled with that one. So I think why is it showing like this? It should have run. Let me use only one. So multi-selector is thank you very much for correcting it. Yeah, that could have been the reason earlier also. No, still not going. Let me remove this app is equal to app one is equal. Started. So multi-labeling doesn't work. That is one scenario. And see here, worker one is, so it has been now deployed on the worker one as because the label was app is equal to prod. So it had got deployed on the specific node.
Can you define app one is equal to prod one? Will that work?
Kubectl get nodes hyphen o wide hyphen show labels. Okay, so guys, I have not applied that app one is equal to prod. It has been deleted already. It is not there specifically, right? And that I think it is not picking up that one. It is not picking up the multi. If I am specifying node selector with multi values, it is not picking up that. Okay. Now, next thing that I hope that this is understood, right? If you want to deploy any pod on the specific node, you can deploy by using labeling it. That is nothing but a node selector. Let me check out if you have any questions so that we can.
So the multiple is not working, right? Multiple one.
No, that is not picking up.
Okay. So we need to note it up. Thanks.
And Ramesh, if we will give this label app is equal to pro to two worker nodes, what will happen in that case?
Very good question. Let's do that one. Kubectl label node worker -02, and you want app is equal to prod, right?
Yes.
It is labeled, right? Now let me deploy it again. Let me make it 4, or let me make it 5 for some time. Same thing, because label is same.
I think it is going to check the available resource.
Yeah, it will get deployed on both one. Sorry. It is going to deploy on both one. It is deployed. Worker 2 and worker 1.
Got it. Thanks.
Okay. So this is about the node selector. But what if that node selector doesn't present, or let's say that you want to deploy on the worker 1 and due to some reason this is not working? What
But
will happen?
Ramesh, don't you think it is a limitation? Why? Because let's say I have 3 worker nodes. Okay, I have 10 worker nodes, out of which 3 worker nodes are production. Okay, and but the 3 worker nodes, okay, they are hosted in different regions. So I have given the labeling based on that. Okay, so now I want my product. I want my pods to be deployed on a production worker node, okay, which is hosted on US East region. So how I can give that? I can't
I
define
think
multiple labels, right?
I think multiple label has to be supported. It is not the way it should be.
No, if you want, let's say that you are saying that you want bot to be deployed on the whose
Yeah, I
type
have
is this one.
two conditions, right? As someone is saying that if we have a production label and it has to be deployed in East region, so there are two conditions. So in that case, we have to have multiple label has to be there, right? I don't know how it will be work, but has to have met two conditions.
For the same worker node, right?
I think at that time F1 was not available.
Yeah, that could be the reason.
Yeah.
Let me just recreate that condition, guys, by labeling the worker 2 as equal to app. Now app 1 is equal to prod, right? Okay, so I have two labels. One is app is equal to prod and another one is app is equal to prod 1. App 1 is equal to prod, and let me set up this one. But the pod was not coming. That was a case actually, but let me check out one more time.
So what you can do, Ramesh, let's say you have 3 worker nodes, or I don't know how many worker node you have currently, but
2 are there.
so
Yeah.
condition might be one worker node has a prod. I mean, both worker node has a prod label, and the second label will be let's say east, and the second worker node will be have a west. Now you need to deploy the pod deployment using which condition has prod plus east label. So it will
No,
deploy
I
instead
got
of
it.
deploying on both
Agree.
label. It will deploy only on the one worker node in that case.
Agree. Yeah, we can do that.
Okay, let us test this first of all. Let me check out if this works or not. So let me use one more replica. Kubectl it is going into pending state. Both conditions are true. which one it will take. So for this purpose, let me do one more thing. kubectl label node worker1 worker dash 01, right? If I'm not wrong, 01.
And there is a typo.
Yeah. And let me use as a disk is equal to SSD. And let me now change this one. And so both labels should be equal, right? But both should be, that means it should be
Satisfied. Yeah.
satisfied.
And
So now in this case, the pod will be deployed in worker 01.
Yeah, it should be deployed in the worker 01. Only thing we are checking it whether it is taking multi-label or not. That is the only case I have to say. Check.
Like if you don't mention SSD label, then prod matched with both the labels in both worker node, and that's why you are deploying all the pods in both the worker nodes. But since you have two labels now, then it will deploy only worker 01.
Right. Let's see whether it working or not. It works or not. First of all, it should. It was not picking up earlier. It is creating a container now. It is not gone into terminal. Yeah, it's working. It's working.
Working. It's working.
It's working. It's working. Yeah, it's working. So
yeah.
Multi-label is working if that condition is satisfied. Now, if I use here app1 is equal to prod, let me change the value rather than keeping the same. kubectl worker2, I'm giving to the worker2.
Or you can have a label region equal to east.
No, I will use this is equal to vadapav.
Okay.
Okay, and dish is equal to vadapav.
Which looks like your hoodie also.
No, to make, see, this is a complete technical discussion, guys. Need to make some fun out of. There should be some smile on your faces, guys, while discussing this.
So it's all about Mumbaikar.
Of course.
I think he likes vada pav a lot.
Right.
Ramesh, we can have fun, but problem is that we are very far from Bombay and we can't get vada pav.
Yeah, please create it. Please make it at home.
I get a vada pav in my place.
Yeah, great, guys.
Bombay
Okay.
chapati.
Okay.
Where are you from?
So
I'm
let
from
us see.
Dallas.
I'm in Irving, Texas.
Oh, I'm also in Irving.
Yeah.
Who is this?
My name is Arun.
Oh, Arun, I think maybe we can chat later on. I'm also in Irving.
So I stay around West Rural and behind old Nokia building.
I'm near to India Bazaar, Jakarta.
All right.
Okay, super.
Please take
Guys,
it off. It is now pending, guys. See, this is not happening, right? Okay, so multi-labeling is happening if you are having, if it is getting satisfied for specific worker node, but if you are trying to on the, yeah, we can use the affinity for sure, but this is something which is not working. So what is not working? This is not working. Let me show you the deployment here. This is not working. If these three selectors or these three particular labels are available on one node, it will work. But if you are using it for the different worker nodes, it is not using. So for that purpose, we'll use something called as affinity and anti-affinity, guys. Okay. Is that clear now? Yes, that's it. Started running. Cool. So that is something called as a node selector. But there is something, some more discussion is still pending because we have to discuss about the node affinity and node anti-affinity. What is it and how it makes appropriate decisions, guys. That is one thing, as well as I'm going to show you something called as a pod affinity and pod anti-affinity as well. But right now, let's discuss about the node affinity. So we have discussed about the node selector, and this is something about the node affinity. So node affinity is similar to node selector. There is no change at all. But there are two things, important thing has come up, that is a constraint has come up. What are the two constraints? One is preferred and another one is required. These two words are very, very important here. Preferred during scheduling, ignored during execution. So quite confusing, right, guys? It makes a lot of confusion after you read this and after you start understanding this one. It says that preferred during scheduling. Preferred is nothing but okay, right? It's okay to have. It is preferable. If I get preferable worker 1, that's fine. If I don't get, I'm okay if it goes on the worker 2 also. That is called as a preferred during scheduling. It is not hard and fast rule that it should get deployed on the worker 1 only. So that time you can use this particular type of the node affinity. But if you are using this required, then it is a mandatory. Mandatory is nothing but if you give this specific stuff to this particular node or pod while deploying the pod, it will not get deployed on any other nodes. It will only get deployed on the node on which you have specified it. So if you define required, that means I want to that pod will get deployed on that worker node only. If it is not there, it will go into pending state, but it will not go into the another node. But preferred during definitely will go there to the if it is not getting placed on the worker 1, definitely you can that pod can get scheduled on the worker 2 as well. So it is not a hard and fast rule. That is these are the node affinity types basically. Because sometimes you say that I need to get deployed. By default, it is required during, right, guys? By default, if you say that no, my pod should get deployed on the worker 1, but there is a possibility that worker 1 may not have that many resources available while deploying that particular pod. So rather than making it fail or keep it in pending state, you can say that no, not an issue. Go to the another worker node and deploy it. So this is the meaning of preferred. This is the meaning of required. Okay, so let's.
So Ramesh, if maybe the quota or resource quota or something when we do discuss at that time, can you do this exercise?
No, this
Say
exercise I'm going to show right now.
You restrict your resources.
No, resources, yeah, I'm going to show you right now. But resources are something like that, node resources or pod resources or container resources.
So, no, you are saying that let's say you don't have a worker, now you have label selected as worker 01. Now worker 01 doesn't have that resources, means the CPU or memory utilization is not too high, and then you need something which requires a bigger size of pods. Then you don't want that pods to be in pending status, right?
Okay.
So
Ramesh,
that's what I'm thinking. If you can create a condition.
I think we need to finish this topic until that. That's the best thing to get the questions.
Yes, that is true. We can absolutely. We need to follow that steps, guys. Please.
Yeah. That's fine. I'm not saying right now, but just later on you can, if you have time, you can discuss.
Yeah, sure, no problem. Okay, so let's deploy this node affinity kind of stuff, guys. Yes. So any question, anybody has any question about the preferred during and required during, only related to this one, because I am going to discuss something else, or otherwise just wait for the questions.
I have a question, Ramesh. I mean, between node affinity and label, okay, which one will take more priority? Higher priority?
No, node affinity also works on the label only.
Yeah, I didn't get that.
It works on the labeling only. The pods will get deployed on the worker node depending on the labels only. But if that label is not available, if that particular worker node is not available, then do you want to schedule that pod on the another worker node or not is decided by this particular two conditions.
Okay, got it, got it.
So let's deploy it now. Okay. So I have all the details are given here, guys. Let me delete this as well. So I can clean up the resources so that it don't get mixed up. Right. And how to remove the labels? This is the way we can remove the labels which I have seen, right? That's fine. The next is that considering pods with the node affinity. So let me take this example, node affinity deployment, right? This is what I wanted to have. Node affinity. Okay. Now you can see this is the one of the script of the deployment. Same script is there. Only see the last stanza here, this para. Okay, what it shows, you are going to deploy the application or pod using the deployment, not an issue. There will be two replicas of it. But where you want to deploy this one, so you are going to use a node affinity kind of stuff. And what is the type you are specifying? Prefer during scheduling, ignore during execution. That means preferably if this pod gets deployed on my worker on the node which is labeled as disk type and whose value is SSD. So we are using an in operator for this one. So key is disk type and value is SSD. If this is matched, then deploy the pod on that worker node whose key and value is this one. But if there is any issue on that worker one node or the specific node which label is disk type is equal to SSD, I am okay if it gets deployed on the another node also. That is the meaning of this one. Preferred during scheduling. So now I need to deploy this disk type SSD and let's see how it goes now. We have to label it. Okay. So here what I will do, I'll just use 4 replicas or maybe a 6 replicas. And now I need to give this label to one of the worker node. Disk type is equal to SSD. So please keep this in mind, guys, in case kubectl label node worker -02 and what label you would like to give. Disk type is equal to SSD, right? This is correct one. So kubectl get nodes -- show labels, and you should be able to see that there is a disk type is equal to SSD label has been attached to worker 1, worker 2. Now let's see. Let me deploy this application. kubectl apply -f. So it shows that it is applied. So basically it should, all the pods should go on the worker 2. So but in case due to some reason if it is not getting, then it should also get placed on the worker 1. Get pods. Can you see now? 5 of them have got placed on the worker 2, but 1 of them have got placed on the worker 1. Right, so this is something called as a preferred. Now look at this YAML file again. There is a weight called as 1. So that is what number I was talking. So you can specify the weight 1 or specify the weight 100 or you can specify the weight 50. So will it make any change if I keep this as a 10 weight? And let me see what happens now. The same scenario is there, right? Oh, I need to change the number of pods actually. Sorry. Yeah, some of them have got worker one. There are 2 pods now on the worker one. The weightage has been changed. I have made it 10. Let me try out weightage to be changed to the 50. So on preferred node 50 is okay. On the other node you can put 50. So let's try. Let me try this 8 replicas now. Now see how many pods are getting created on the worker 1 and how many pods are getting created on the worker 2. Let's watch it. So most of them have got created on the worker 2 only, right? So only 2 of them have got created on the worker 1. Rest of the 6 are there on the worker 2 only. And what will happen if I give 100% here? The labeled worker nodes weightage is 100%. So what is the meaning of that? Let me see. So all of them are getting created on the worker 2 now. 8 remaining 8 one. Now the situation remains same, right? There are two pods running on the worker 1 and the remaining 6 are running on the worker 2. So what is the meaning of weightage, guys, here? This is something interesting to understand. Weightage is nothing but weightage is given on the depends on the number of resources. Who is having more power right now? Who is having more vacant resources right now? It can be from the disk pressure, memory pressure, or CPU utilization, RAM utilization, or number of concurrent connections. All that makes one weight, right? So what is the meaning of it? If this is your 2 worker nodes, this is worker 1 and this is worker 2, let's say. Maximum value is given is 100, guys. Minimum is 0. Okay, but how to calculate? Because this worker 1, let's say that right now having a, that is what the way I told you, this is 100, let's say score is 10 here. Let's say the score is here 10 to start with. So when I say 10, that means 100%. They are free now, nothing is there. So now suddenly what happened? One pod has got deployed here. So moment the pod has got deployed here, whose weightage is more for the next scheduling? Whose weightage is more for the next scheduling? Let's say now again somebody is saying that deploy one more pod. So whose weightage is more? This one, because it is having a 10, it is having a, let's say, 9. So what your Kubernetes will do with the help of API server, it will deploy the pod on this one. Now both of them are becoming 9, but there is another constraint here that this pod might be requiring some less CPU, but this pod is requiring more CPU, or maybe more RAM, or maybe there it is having more number of connections now established. So it is using a more resources of this worker too. So even if this is having only one pod, its score can be 8. And this score is 9. So whenever the next cycle comes, So your API server will inform to the kubelet according to the scheduler that deploy the pod on the higher weighted one. So who's having more weightage? This 9. So pod will get deployed here.
So how it get means like calculated in the backend?
No, that is a scheduler algorithm that we need to check. I think it is using a raft algorithm, if I'm not wrong. Behind to check the scheduler, this one. RAFT algorithm is there. It is using that one. I need to check it, which algorithm is used, but I feel that is using the raft algorithm. Okay, now, so what will happen now? It may use the 2 points here. So it becomes 7. And it is now 8. Sometime later on, again, the pod will go on this particular node. Then this becomes 7 and this remains 7 only. Or maybe this becomes 7.1 or something like that. So again, weightage is to this one. So there will be fractional changes definitely, guys, in each worker node, depending on the number of resources it has been used. So always.
But then in that case, Ramesh, the pods would have deployed evenly, right? In our case, that is not.
No, in our case, what is happening? In our case, we have said that if my weightage is 10 on the preferred node, or weightage is 10 or more than 10, deploy the pod. Okay, so there is a possibility that worker 2 has most of the time weightage more than 10. And it is preferred. The first preference is to this one. But we are saying that if the weightage is more than 10, always. So if their count is 100 here and 100 here, so there is a possibility there that most of the time this worker node has a more score than 10, and that's why it is deploying it on. But while deploying, there is a possibility that
the weightage is calculated based on the available resources.
Yes, available resources. So it is similar like the weighing machine which we use, right? There are two. If there is one, you are trying to weigh something, right? So it is a balancing act.
But I believe in our case, as both the worker nodes has been spinned off from Azure, okay, and they both have equal configuration, okay. None of the work. I mean, when you compare both of them, worker 1 and worker 2, they both have equal number of CPUs, storage, memory, everything, right? So in that case, worker 1 should be having more weight compared to worker 2.
No. We have seen the condition is that preferred one is this one.
No, preferred one is this one. But then when you compare the available resources, worker 1 will be having more resources compared to worker 2. Why? Because more number of pods are deployed in worker 2 compared to worker.
No, that is now this is 8 GB. We have to calculate that. This is 8 GB. Let's say this is 8 GB. It has 4 cores. It has 4 cores. So when we calculate the percentage of the utilization, it might not be less than 10% at any point of time. Or there is a point where these two resources has got deployed. That time there is a possibility that some of the resources might be using more here. That's why it has got in that fraction of second. In that fraction of second, the worker 2 might have gone down the score less than 9 compared to this one. That's why these two pods have come up here. So what will happen if I try here 100 pods? Will all of them will get deployed on the worker 2? Preferably on the worker 2 only, but the weight we have used is now 100 here. So let me change this weight and let me make it 10 and try to deploy, but this will be too much number, right, guys? We will not be able to calculate that. Let me make it 20 and kubectl apply -f node affinity dash deployment YAML. Okay, now let's watch. See, some of them have got deployed on the worker 1 as well. See, Some of them are on the worker 2, some of them are worker on the right. So it depends on how many current pods are there, right? The moment it is deploying the pod, that time if the CPU utilization of one worker node is going high, that is also calculated for the weightage. That time it feels that, oh, on the another node there is no CPU free, let's deploy that over there. Okay, so that is what weight is. I hope that that is clear now. Okay, so what will happen if I use the command here called as required? If the required during scheduling, if you mention here, then none of the pod will go on the another worker node. Okay, so let's see that now. So let me delete this one, kubectl delete. So that it will get freed up. And now let's try out the node anti-affinity. So all of them are getting terminated. Cool. Now let's try it. Node anti-affinity is nothing but required during scheduling and ignored during execution. That thing that we are going to now execute, right? So required during scheduling, during execution, this constraint we are going to now check it. So this is my YAML file. And here it is mentioned required during scheduling, and expression is this type is equal to SSD, and how many pods you want to deploy? 2. So whatever the situation is, it will not go on the worker 1 at all. It will only go on the worker 2. Even though if I try 20 replicas here, and whatever the issue of the weightage here, weightage will not be considered here at all. Right? Let me save here because it is mandatory. So kubectl apply -f node affinity dash deployment.yaml. What is happening? Yeah, now it is showing deployed got created. Let's see then what is happening. Kubectl get pods happen over wide, and all other pods I have deleted. What has happened? None of the pod has got deployed. I don't know whether this image is available now or not. Let me change it. Disk type is equal to SSD. That is what we have written.
We can reduce the number of replicas also if you want.
Yeah, that is also true. But that is not going to make any changes. Let me make it 6. It has started now. Oh, earlier it was created. It was not displaying here, but it was created. And look at this. All of them have started on the worker 2. This is required. None of them is having started on the worker 1. This is your anti-affinity, right? Sorry, this is a node affinity basically, but it is required during execution. That means whatever the weightage is there, now worker 1 is completely free, but it will not go on to worker 1. It will just deploy it on the worker 2 only because it is mentioned there like that.
Why we have to use this? It is not needed until unless you have done your labeling correctly. I think you don't have to mention node affinity or anti-affinity, whatever the required field. Why? Because as per the labeling, it will create the pods on the required node.
No. If you as per the labeling, right? Yeah, in the labeling that is possible, right? But in the
Yeah,
labeling,
if
it
I
is
have
not like
given
that. If you no in
if I have given
labeling,
disk is equal to SST for one worker node one, and I have not labeled disk is equal to SST in worker node two, okay, even doesn't matter whether you define that node affinity or not. Irrespective of that, it is going to create all my pods in worker node one, where I have defined which I have labeled as SST is equal disk is equal to SST.
yeah, that is true. That is true.
But Ramesh, here, let's say the requirement is, let's say you have four workers nodes, worker one, worker two, worker three, worker four. Two are prod and two are dev. Now you have a label called, uh, the app equals prod and app equals to dev. Now you know that app equals to prod. You have put the label in both the worker one and worker two as prod label defined. Now you also need to put node affinity that, okay, I want to select a label which has prod, but out of that prod I need to deploy the pods maybe 50-50%, right? It should not go into worker one 100%. And I want to put a node affinity, a second condition, where four nodes will be deployed in worker one and four nodes will be deployed in worker two if you have deployment as replica set 8. In that case, I think we can use this, right?
Right, yeah, that is true. And another is you can use 50% weightage there, right? 50 value. So there is a chances that possibility it will get distributed equally. Yeah, and in that case, we need to use the anti-affinity, that is this required phase or preferred phase over there.
And moreover, I think irrespective of whether you define weight or not, okay, it is going to the kube scheduler is going to decide, okay, where I have maximum resources available, and it is going to deploy it there.
Right, that is also true. Correct. Yes, that is absolutely correct. And
No, but
but
Sumanta, we can. I understand that scheduler will automatically know which resource, which worker node has a more resource. But a customer wants, let's say, I have worker one, which maybe in future I will add more resources, right? In worker one, but in worker two, I might be decom, or later on we don't want to add more resources. And but current scenario, we have worker two has more resources, compute power and CPU power and memory power. But I don't want to exclusively, I don't want to define the node or deploy the node in worker two, but I need to restrict my utilization only on worker one as a prod label, which has both nodes. In that case, you have more better control. Then you need to use a node affinity feature, I believe.
right, correct.
Because
That is
we have
yeah.
seen that irrespective of the node affinity, it is not acting or behaving the way it should be when it comes to node affinity, the preferred. Okay, it is. I mean, kube scheduler is doing its own analysis and calculations, and based on that, it is deploying the pods. I mean,
No,
because it is preferred.
basically that value is taken as a reference value. Okay, if you don't give the weightage, then it may not distribute evenly also, or there is a possibility that on one node it will be more pods will get deployed, another on less pod will get deployed. That is possibilities there. So by weighing condition, you can trying to at least come to the closure side, closer to the balanced one. That is actually the way you can.
Okay.
And another important thing is that uh, if you modify any, if you let's say deploy a deployment with some preferred way or a preferred way, let's say with some weightage, and so it has started running on the worker two, and later on I change the weight, and now again I'm deploying it. So it is not going to change anything from the current worker node. Current pod status will remain on that worker node only, right? So if you are going to deploy any future pods, so weighing capacity will be calculated or used for future pods, not for the current pods which are running right now. So that's why you may see that unequal or unequal distribution on the pods in the cases which you have seen right now. Okay.
Somehow, Ramesh, I'm not getting confidence on this weight attribute. Why? Because we have two node affinity, node anti-affinity, preferred and required. Okay, and you are giving preferred and weight. Okay, just to make sure that you are following the required attribute, conditions. Okay, so yeah, you you are defining preferred and you are giving weight. If you are going to do that, better you use required. Why are you using two attributes?
No, the condition is that you don't want to fail any pods, right? If that it doesn't get, if you are specifying required, and if you don't have the enough resources on that particular, with that particular worker node is filtered because of some reason, your all deployment will get collapsed. That's why we have to
Actually,
keep it.
we are I think we are manually intervening, okay, the job of the scheduler, because the scheduler is intelligent enough to find out, okay, in which worker node I have more resources and which is capable of handling more pods.
See,
Okay, so
basic reason for the pod node affinity is if you want to deploy your application which has a specific hardware needs, that time
okay,
node affinity is used. There is a
okay, got it.
purpose for that. There is a purpose for that. And if you want to read that one, if you want to know more about that one, you can just type here Kubernetes. What is that topic which you are discussing? Node affinity, right? Node affinity. And you will be able to see that over here somewhere. What is the need of the required, or what is the need of the node affinity, right? So scheduling a pod using required node affinity. So it is required during scheduling. This is specifically for required. That means it will not go deploy anywhere, right? So, but they have specified why you need to use the node affinity and where you want to use it. So
Yeah,
let me
yeah,
just.
right. I mean, we scheduler is basically just to deploy wherever the resource is available, right? But it is not going to check the another condition. But you have a specific reason. Okay, I need a some kind of block storages, NFS instead of that, or maybe SSDs. The second condition or something which you want exclusively to deploy your pods in worker one, whether resource is available or not available doesn't matter. But I want to deploy my resources, my pods into worker 01. Then you can put that condition.
Then
Right.
in that case, use required. Why we should be using?
No, there are conditions are there. That's it. We can check it. But I'm just trying to show you this documentation where we can find out what is the need of scheduling. So that documentation is given. So preferably, if you get a chance to read that one, you can
Yeah,
go
Ramesh.
through.
Yeah,
Mm,
yeah.
mm.
Okay.
But there is a
So
very
let's
nice
move ahead.
document.
I mean, we can go through the documentation to understand, okay, what is the significance of preferred, required, weight.
Yeah,
So
it
all
is.
those stuff.
No, they have specifically written this and node affinity is specifically required when there is a specific need of the hardware for that specific application, right? And why
Application.
should, yeah, right? Why should we that during that one? Let's say you have 10 worker nodes are there, and for one application, why will have the similar worker nodes, right? Which requires a different kind of configuration. So you can just put that worker node there, which is having a specific hardware, and you just put all the deployment application on that worker node. So there is a specific reason for that.
Okay. So can you give me only one example, okay, where I can't go with any other combinations, okay, or attribute values, okay, and I have to go with the preferred one with weight.
So you have a problem with the preferred one, right? Okay. No, that's
Yeah,
a
I
good
mean,
answer.
unnecessary. I think unnecessarily they have imposed one thing. Okay, when you have this required, and when you have Cube Scheduler, which is an intelligent tool or a utility, okay, which is going to do everything for you. So why we are intervening? I mean, what's the use
No.
of preferred?
Kubectl doesn't go according to the labeling, right?
Yeah.
Labels are
So
used. use the
Yeah,
affinity.
label. No, I'm just finding it difficult to understand what is the use of this preferred, and then on top of that weight.
The preferred is used in such a case that when you have a disk, when you have a specific label called as, let's say disk is equal to SSD, right? Try to deploy the application on that one. That is my first need. My application need is that it should run on this particular node only. Okay, but I don't want it, even though let's say that if the resources are not available on that one, I'm okay if one of my pod runs on the another worker node as well. Okay, so that time you can use a preferred one. What happens in the required? You don't have chance to go to some other nodes. Right?
Means we are forcing it to go to one node.
Yeah, in the required we are forcing it to go to the one node, but in the preferred we are giving a flexibility. That is fine. My first need is that it should run on this particular node.
No,
but it's yeah.
No, but the question is here that what Sumanta is saying, that in the preferred it is fine, that okay, if it is not there then it is there, but in the required one, why the what is the weight is coming in between?
Right. No, his question is actually reverse, right, Sumanta? If I'm not wrong.
Yeah, my question is reverse. Yeah.
His question is that why preferred? That is his question.
So where is anti-affinity comes into play then?
Anti-affinity comes into present when you don't want to deploy the pod on specific node. That
Yeah,
time
so with using that we can restrict applications to go into the node, and critical applications we can use the required and go to the specific node. So certain times the pods are very important and they are required to run in particular, the container is required to run in a specific node, and that time we require to have this. These are required for real-time applications where different type of applications will run as running the traffic, and different type of servers will run as configuration data, and that should be always fixed.
Yeah, that is also that is one of the use case. Can you see that in the production, if you have the same application is there, but having a different models and interdependent models are there, and you want that model to be executed on two nodes, and two of them want to run on the two of them. So that time also you can use this story, right? Anti-affinity, node affinity kind of stuff.
So
okay.
Ramesh, I understood this thing. I mean, if you have specific requirement and you want the application, sorry, the pod to be deployed where the disk is equal to SSD, preferably. Okay. So that doesn't mean that it has to, but then if you found that any node, any worker node is having disk is equal to SSD, then preferably you host it there. Okay. If no, then you find some different worker node.
Yeah, right? that is the thing. Right. My priority is that it should run on this one. That is my priority. I'm deciding priority. But okay, even though that priority doesn't meet, I'm okay if it runs on the second. That is the way it goes.
And when you give on top of it, when you give weight is equal to 100, what does that mean?
So weight is going to that means if it is 100 weight, that means the number of resources. I'm preferring that weight should be given 100 to my preferred node, right? So that most of the time, whenever my resources are available, it should get deployed on my worker preferred node only. That is a weight 100% is. So basically,
so preferred plus weight is equal to 100 is
that's
not equal to
secondary
required,
condition,
right?
Weight is secondary condition.
Yeah, that's a secondary condition.
Yeah. So
right.
Secondary condition. So no. So preferred plus weight is equal to 100 is not equal to required, right?
No.
Okay.
No. See, if 100 weight is nothing but it is actually low. It goes into the lowest priority. And if you have a 0 weight, that means it has at the highest priority. But that doesn't mean it is the required condition.
Okay, got it. Thank you.
It is not. Yeah. All right. Okay, guys, I think we have had a fruitful discussion today. I hope that you got something out of this. What is the point remaining from this advanced scheduling is that I think only a couple of points are remaining, not more. That is anti-affinity, node anti-affinity. That is one thing remaining.
Taints and
Yeah.
toleration.
And taints and toleration. That will come into the anti-affinity, right? So that we'll discuss in the next session, guys.
So this Ramesh, all this the whatever the algorithm you indicated is for the one which is we are deploying new, right? I mean, whatever current running it will be there, but again when it comes to deploying new, so that's where weightage, preference, or required will come into picture, right? That's how we have to think it, correct?
Yeah. So yes, correct. If you let's say 10 pods are running right now, it won't get affected. It will be for the new pods which are coming. If you're writing some policy or you are writing some pod node affinity or node anti-affinity constant rules, that will come to the future pods, not for the current pods.
And to remove that affinity or advanced scheduling, I have to go to YAML file and remove that so that it will work normally, right? I mean, in case if I want to roll back to that, correct?
Correct. You have to remove the node anti. Yes, correct, absolutely. Yeah, and there is one more concept that eviction is there that we'll see, guys. Not.
And Ramesh, I think next session, you are going to tell us about the NFS configuration file, right? Config file.
Yeah, I will try to show that. Yes, I should get it. Yeah, I should get that. Anything else that you feel that guys need to be done in the next session? Let me know that.
So,
Yeah,
Ramesh, like on the next time, sometime like all will there be separate session for troubleshooting? Like I mean, just troubleshooting. Okay, this happened. This I mean, other than going to
Yeah,
log.
we have one lecture for the troubleshooting.
Oh, separate session. That's what I want to know.
Yeah,
Okay.
yeah, it is there. It is there.
Okay.
Yeah.
Ramesh, you have some you can solve some dumb or some preparing for the certification or something like that.
Rishi, your voice is really not coming up properly today. I think there is some problem with mic.
I'm really sorry about that.
Really, it is little disturbing. It is coming in the let's say patches. Please ask the question, but all right, guys. I think that's it. Rishi, are you coming back? Are you just trying to write a question or how it is? By
I'm
chance, do you
sending
have?
the question.
Yeah, this guide is there, Rishi, for the certification. I think K21 that on the portal they have given there's a 2 hours, 2 to 3 hours recording is there for the certification. Documentation is also available. You just follow that. It is on the it is basically on the portal only. Am I correct, Piyush?
Yes, correct, Ramesh. All the guides and practice question and everything available on the portal.
Okay, thank you. All right, guys, that's it for the day. Enjoy the weekend. Now weekday will start. All right, thank you.
Thank you.
Take care. Bye bye.